Welcome. PIO 205. Study Section 2. Blood System. Introduction. The blood system is an integral part of a living being, without which most body functions will be hampered. The blood system can be divided into the cellular and fluid parts. The cellular parts are red blood cells, RBC, white blood cells, WBC, platelets. Blood is a connective tissue with a complex liquid intracellular material called plasma. It is seldom defined as a connective tissue, which provides one of the means of interaction between the cells of and from different body parts within the environment. It is made up of about 7% of the total body weight and about 5.6 liters of a physiological man. Learning outcome. Learning outcomes for study section 2. At the end of this study, you should be able to explain the components of the blood, explain the functions of the following in your body: the red blood cells, the white blood cells, and the platelets. Components of red blood cells. Blood is made up of two main components, a plasma and cellular content. Plasma is a straw-colored liquid component of blood on centrifuging. It makes up about 55% to 57% of blood volume, comprising the following: water, plasma proteins, clothing factors, fibrinogen, albumin, and globulin. Hormones, enzymes, antibody, immunoglobulin, organic waste material, creatinine, urea and uric acid, gases, oxygen, nitrogen, and carbon dioxide, nutrient material obtained from broken down ingested food, glucose from carbohydrates, amino acid from proteins, vitamin from most food, fatty acids and glycerol from fats. Inorganic salts, sodium chloride, sodium carbonate, potassium, magnesium, iron, calcium, iodine, and cobalt. The main functions of blood are: 1. Regulation of homeostasis. 2. Transport of end products of digested and other substances to site of need, e.g., oxygen, carbon dioxide, etc. C. Plasma and platelets in blood contain all the clotting factors which help in preventing bleeding. 4. Antibodies found in blood are essential for the development of immunity, that is, resistance to infection. Red blood cells. Red blood cells are also known as erythrocytes. They are biconcave, non-nucleated disc with a diameter of 7 to 7.5 micrometer. This shape allows for a volume with which it can accommodate greater diffusion surface for the passage of gases. Like many other cells, a mature red blood cell consumes oxygen, glucose, and adenosine triphosphate (ATP), as well as it releasing carbon dioxide. The red blood cell have a lifespan of 120 days. The average value in males are higher than females, mainly because of males have a larger or greater mass of muscular tissue, which requires a greater amount of oxygen supply compared with females. The main sexual characteristic hormone in males, testosterone, stimulates the production of more red blood cells. Greater oxygen utilization increases the production of red blood cell. Within the cytoplasm of the red blood cell is the hemoglobin, without which the red blood cell is incomplete. The red blood cell is produced at different sites within the growing fetus and man. Thus, at the early few weeks of embryonic life, the red blood cell is produced in the yolk sac and it is nucleated. At the middle trimester of gestation, it is mainly through the liver and spleen. At the last month of gestation, It is produced exclusively by all the bone marrows until the child is 5 years. By the age of 20 years and beyond, it is produced by marrow of membranous bones, e.g., vertebrae, sternum, ribs, and tibia, that is, all flat bones, irregular bones, and epiphyses of long bones. 3. White blood cells. The importance of the white blood cell is captured mostly in their functions to fight invading infections and boost the body immune system. White blood cell, as it is generally called, is also referred to as leukocytes. They are fewer in number when compared with red blood cell, though larger in size. They are soft nucleated cells of between 4,000 to 11,000 cubic millimeter and account for about 1% of the blood volume. The main functions of the white blood cell are: they digest dead tissue. They help to fight bacterial infections through the process phagocytosis. The two main types of white blood cells are granulocytes, also called polymorphonuclear leukocytes, which include neutrophil, eosinophil, and basophils, make up about 70% of all the white blood cell. The main distinguishing feature of all granulocytes is the presence of multilobed nuclei within the cytoplasm. Agranulocytes, of which are monocytes and lymphocytes. Differential white blood cell count. The number of circulating phagocytes considerably varies with the physiological condition, age, activity, and sex. It varies in pathological states, ranging from a mild respiratory infection to acute leukocytosis, a severe drop in white blood cell number. Immunity is the body defense mechanism against invading organisms. There are different types of immunity for the survival of the human being against diseases. 4. Platelets. Platelets found within the body system are saddled with the task of arresting bleeding. Their importance and function will be explained in this session. Platelets are small, tiny, non-nucleated discs of about 2 to 4 micrometers in diameter with a lifespan of 8 to 11 days. A third of all intact platelets are found in the spleen. The normal blood platelet count is about 200,000 to 350,000 per cubic millimeter. Platelets function in the maintenance of normal blood vessels and repair of ruptured blood vessels. Packed cell volume is the percentage of the red blood cell to the total blood. Hemostasis. This is a series of reactions occurring to prevent or arrest loss of blood from a ruptured blood vessel. It occurs in overlapping stages which can be categorized into 3. A. Local vasoconstriction, formation of temporary hemostatic plug, clotting mechanism or coagulation. Vasoconstriction. During a mechanical trauma associated with sperm, the sympathetic reflexes are triggered, thus leading to release of vasoconstriction chemicals, chiefly serotonin, liberated by the platelets, which have adhered to the sticky surface of the damaged tissue. Serotonin then constricts the vessels as a result of growth spasms, thus reducing the flow of blood from it. Temporary hemostatic plug. When the blood vessel is damaged, endothelium is destroyed, thus leading to an exposure of the underlying collagen layer. This layer then attracts platelets which adhere to heat, thus liberating adenosine diphosphate and serotonin. These two release substances then attract more platelets to the damaged vessels to form a loose plug of aggregate platelets. This mechanism is under a positive feedback mechanism. Blood clotting or coagulation. This involves an interplay of the 12 clotting factors. Fibrin helps the lost aggregate of platelets bound together to be converted to a definitive clot. This then traps blood cells, thus making a stronger thread-like mesh when compared with the loose plug of aggregate platelets. The two pathways involved during blood clotting are intrinsic and extrinsic. Summary of studies section 2. In this study, you have learnt about the red blood cells are also known as erythrocytes, and that they are biconcave, non-nucleated disc with a diameter of 7 to 7.5 micrometer. The importance of the white blood cell is captured mostly in their functions to fight invading infections and boost the body immune system. Platelets found within the body system are saddled with the task of arresting bleeding. Now we've come to the end of study section 2. Thanks for listening.